Always check that on your calculators, nothing wrong with that. Into the home stretch, the 5 points of the parabola. I am first off going to ask myself, what is the minus b over 2a, the axis of symmetry? And I plug in minus a minus 6 over 2 times 1. I get 6 over 2 equals 3. So I go to positive 3, 1, 2, 3. And now I take that 3 value and I plug it in. So I get y then is equal to 3 squared. Show it just like this. Minus 6 times 3 plus 5. I get 9 minus 18 plus 5. That's what my y is equal to. And finally, y is going to be equal to negative 9 plus 5 is negative 4. So I go down 1, 2, 3, 4 right there. My parabola then, I'm going to find the y value, 3, negative 4, label your vertex, and I look at plus 5, so I'm going to go 5, 10, like that. And there it is, right at 0, 5, that's that point. So I know that it goes and it opens up like that. It's going to be symmetrical, so if this has a distance of 3, this will have a distance of 3 to this point, and it's going to open up through that. And that's going to have coordinates of 6, 5. Always double this coordinate right there. All I'm looking for now finally are these 2 points. These are the zeros. And I do that by factoring, so I go back, and this is why I've learned those factoring skills. I say x minus 5 times x minus 1 will give me the factored form of that, and it's set equal to 0 because this is the y equals 0 line, so y turns into 0 right there. When is this equal to 0? When x is 5. 5 gives me a 0 right there. When is this equal to 0? When it's 1, so that's 1, 0. And there are my 5 points of the parabola. Label them as they should be labeled. All right? On to solving by factoring. Actually, it doesn't say by factoring, but you're supposed to know that. Or actually, in this case, this is not cubic. This is just to test to see if you're paying attention. That is linear. So I go 3x equals 7. I add 7 to both sides. X then is equal to 7/3. Or you could write 2 and 1/3, but either way is good. This is a quadratic, so I just do want to factor this. And when I do, I get x and minus 7 and plus 1. When are each of those equal to 0? You must write the solution. Us teachers like set notation or bracket. 7 and negative 1 is good. You can just write x equals 7 or x equals negative 1. Circle your answers. Make it clear what you're actually saying. Same deal goes here. I'm going to factor. These are easy to factor, but first I'm going to subtract. I'm going to make that minus 27 equals 0. And then I've got x and x. Numbers that multiply to make 27 that have a difference of 6. That's going to be minus 9 and plus 3. When is that equal to 0? We've been asking this a lot. You should be able to do this automatically. X is 9 or x is minus 3. Do not repeat, do not forget to write the actual solution. Here I have to do some simplification, gather up all of my like terms. I've got x squareds on both sides, subtract the smaller from the bigger, I get x squared. Then I have to bring everything else to be with the x squared. I subtract 7 from 4, I get minus 3x, and I take away 10, and I've got that set equal to 0. Shove everything over, set it equal to 0, and drop the factor bomb on it. X, and I go minus 7, and whoops, 7? I don't think so. Minus 5, and plus 2. Alright? So that gives me a negative 10 when I multiply, and a negative 3 when I add. Don't forget, equal to 0. When does that happen? When x equals 5, or x equals negative 2. Okay? Finally down here I've got a little bit of distributing to do. It's a little bit ugly. I get x squared and then plus 17x squared and then plus 17 times 3 is 51x, and that's equal to minus 8. Oh my goodness, who thought up this problem? You just have to crunch through it. That's a total of 18x squared plus 51x plus 8 equals 0. And now factor that. Okay, if you need to get a chart out, a box method, you can. I didn't put it here, but I could. I'm going to squeeze it in right here. This is the type of thing you're going to have to do on your own. And I put 18x squared, and I get 8 right there. And when I multiply, that's 80 plus 64. That's our favorite 144 again. And that is plus, and so I do 144. I'm sneaking it in there, x squared. And I'm going to make my little factor chart here. 1 and 144, and 2 and 72, and 3 and 48. This is again our 51. I think we've done this before. And I'm going to write then 3x and 48x right there. And again, I'm going to circle this and say, oh, look at that. That's going to be like before, 6x, when I divide everything by a 3, plus 1. 6x plus 1 is going to be multiplied by 3x plus 8. All right, so this is the same problem from before, just seeing if you're paying attention. And so now what are the actual solutions there? Well, this is when x, I write little 6x plus 1 equals 0. When is that? Question mark. Well, when I subtract 1, I get 6x equals negative 1, and when I divide by 6, I get x equals negative 1/6. All right, that's one solution. When I solve for this one, I will get negative 8 divided by 3, so I get or x equals negative 8/3. All right, so that's sneaking in. That's the answer to number 16. That's it. All done.